When doing the 90-degree launch, we began by pouring water into the pressure chamber until the rockets reached 80% of their filling capacity. We then placed the rockets on the launch tube, adjusted the fins, and made sure that the nose cone was facing directly upward at a 90-degree angle. We then waited until the rocket was fully pressurized and pulled the string that would release it from their launch apparatus. We recorded the launch and resulting flight impact with the camera so as to obtain an accurate reading for the rocket's time in the air later on. This aspect of the lab taught us the practical uses of the range, acceleration, and distance formulas, as well as the importance of proper engineering, attaching vital components with care, not with insufficient cheap materials. Next time, we would use more practical methods of attaching the nose cones to ensure their attachment during and after the launch. We also could have launched on a day with absolutely no wind, which would have resulted in a straighter path for the rocket. Although we eventually were able to successfully launch the rockets, we did encounter some setbacks. One of the rockets managed to find its way into the river. It was a windy day, and we lost almost all of our nose cones. We managed to get 2 usable 90-degree launches, and were able to use the data collected to find the range and distance. We found time in the air by using a stopwatch and later by reviewing the videos that we took of the various launches. We then used 32 feet per second squared and 9.8 meters per second squared for g and found vi by using the formula acceleration off the shaft equals v2 minus v0 divided by time on shaft. And finally, during the 90-degree launch, we used 90 degrees as theta. Our whole group participated in the 90-degree launch. We had one person pull the string to launch the rocket, one person filmed and photographed the launch, two people helped to fill the rocket, and we had another group member timing the launching. We cooperated, though there was some dispute over who was to actually launch the rocket. This is an interesting part of the lab, and we liked the hands-on aspect. Also, we liked that the results were clearly visible due to the outside vectors. None of the rockets launched straight down, as they should with a 90-degree launch. However, it was interesting to see where they did land. We did not like how easily the rockets could be affected by the wind and other similar factors. Additionally, we did not like that the launching was weather dependent. During the 90-degree launch, we learned to take our time with the construction of things that are so dependent on outside factors, such as our rockets. This is also true when building practical things, such as construction projects like working on houses or building sheds. Wind, rain, and other factors make a big impact on those projects, so completing them with no mistakes is very important. We also learned how to allot roles, such as launching the rocket, filming the launch, and etc. This will be useful in other future projects, both in school and out, which require group work. This launching was not like any other labs we completed. It was far more time-consuming and work-intensive, and the results were visible immediately, unlike most other labs. The 90-degree launch should be kept for other years because it is an essential piece to the other launches, 45 degrees, and it allows a basis for comparison for the other launch. Finally, it illustrates essential physics concepts and the impact of outside vectors.